torque on a current loop, but first we will discuss the equation which we were talking about yesterday. So this is the equation which I was telling you that suppose we have a length L through which the current is passing by. This is the length L of the wire which we will consider it, and it is current is passing by. So the current that we know that current is equal to Q by T, or we can say that it is equal to Q is equal to IT. Okay, you already have studied in FSC that current is basically, just hold on a second, beta, I is equal to Q by T. Here it is, I is equal to Q by T. So obviously Q will be equal to IT. So this equation is coming from this end. Okay, and how we will get the time? So time is basically the S is equal to VT. S is equal to VT, and here we are taking the. एक second, beta, just admit करना. So here we are taking time as S T is equal to क्या आएगा बेटा? S by V. So the length here in our case is equal to L, while the velocity of the electrons, we are taking the velocity of the electrons. So electrons when move within the material, they have the drift velocity. Okay, so we will write it as Vd L over Vd. So this relation which we are getting here is like this one. Okay, so this is the relation here. So we will just put the value of T in this equation, and this equation will become something like this. Okay, afterwards we do know that the magnetic force that acts on a charged particle, single charge particle, is this one, which is equal to F is equal to Q Vd B here, and we will put the value of Q here, which is IL over Vd from this equation, and the final result that we will get is equal to ILB. And we also know that this is the scenario for the this is scenario when we have the magnetic field perpendicular. Okay, so in case when we have do not have the magnetic field perpendicular, then in that case, what will, let's suppose this wire is acting at some angle with the magnetic field. So for that case, we will use this relation, which is IL cross B. So or we can write it as like this one. Okay, ILB sine phi here. Okay, so this is the relation when you have a wire, straight wire, and you want to find out the magnetic force due to that current carrying wire within the magnetic field. In case when we have, this is the scenario which I was talking yesterday, that in case if you do not have a straight wire, you have a curved wire. So what you will do is that or if you do not have the uniform magnetic field, then what you will do is that you will divide the wire into small segments, into very small segments. We in small segments we can consider depending upon the type of irregularity. Okay, and then we will take the differential part of this wire, which will, and obviously when you are taking the differential part of the wire, obviously which is equal to dl length, differential length, because we have divided it into the small parts. So one small part will be equal to dl. So in that case, the magnetic force that that rises due to this that small segment of the wire would be equal to this one, I dl cross b. So up to this point, is it clear to you? Any question up to this point, beta? आवाज आ रही है बेटा?
जी सर, आ रही है आवाज.
Okay. Yes, so sir. This is the okay. So any question from this article? So then we will move toward the next article, beta.
नहीं सर, क्लियर है.
Clear. Okay. चले अब आ जाते हैं toward the एक सेकेंड बेटा दीजिएगा, न्यूमेरिकल की तरफ आते हैं हम लोग. Okay, so the next numerical is related to this magnetic force. So what he is saying, let's suppose you have a straight horizontal length of copper wire which has a current of 28 ampere through it. What are the magnitude and the direction of the minimum magnetic field needed to suspend the wire? Means that you want to suspend the wire. In order, how it can be suspended? That is to balance the gravitational force on it. ठीक है कि आपके पास जो फोर्स है ठीक है let's suppose gravitational force is acting downward, so magnetic force should act in the upward direction so that the wire can be suspended. This it is just like the magnetic levitation, in which you already have studied that what is magnetic levitation is. It is basically when a body suspends in the air rather than contacting with any surface. Okay, so for that purpose what we are going to do is that we are going to balance the gravitational field with that of the uh, magnetic force. So this is the scenario. The linear density of the wire is 46.6 gram per meter. So how we are going to do it is basically we will use the relation FP is equal to ILB, and since we want to balance it with the gravitational force, so FP is equal to ILB. So ILB sine phi would be equal to mg. Then we can say that okay, both of these are balanced here, like we studied in the case of the Hall effect, or we studied in the case of the cross fields, when the electric field becomes equal to the magnetic electric force become equal to the magnetic force. So here in this case we are balancing the gravitational force and the magnetic force due to the current carrying wire. Okay, so we will take these two relations equal. ILB sine phi will be equal to mg, and then we will rearrange the equation in order to find out the minimum magnetic field that is required. So B would be equal to mg, because IL over sine phi will move in the denominator on the other end. So mg over IL sine phi, or this can be written as mass per unit length, because here we and they have given the linear mass density. Okay, so linear mass density is basically equal to mass per unit length. So this factor, this you can say quantity L will move like this one. We will take it like m by L. It will become mass per unit length. The value of mass per unit length is given by, which is equal to 46.6 gram per meter, but we will convert it into the SI units, and it would be 46.6 into 10 power minus 3 kg per meter. Okay, and then there is a gravitational G force acceleration, and then at the uh, bottom there is a I here. So angle we are taking here is 90-degree in order to balance it. So after putting the values, the minimum magnetic field required to balance the uh, Earth's gravitational field is this one. Okay. So any question about this numerical or the example here?
नहीं सर.
Okay, fine. अच्छा, अब आ जाते हैं हम लोग towards the torque on a current loop. Okay, you already have studied in FSC that when you have a loop or the coil of the current within the magnetic field, a torque acts on it. Okay, and which basically rotates it. It is principle of all the electric motors like AC motors and that of the DC motors. And I think you already have studied in FSC that how it works. So here we will discuss in detail, and we will find out how much torque X on a single loop of a wire, and then we will take that if we will consider that if we have n number of loops, then how much a torque will act on a coils. Okay, within the magnetic field. So this is the coil. This is a simple example. Okay, we have the simple loop of a wire here. This loop of a wire is suspended within the perpendicular within the magnetic field. Okay, and when we will suspend it within the magnetic field, what will happen that it will rotate. Okay, and how it will rotate, I will let you know. Okay, how it will rotate and how much force is acting on the each side of the wire here. Okay, So कहता है कि let's suppose उसमें उसने बताया कि आपके पास in this figure shows a simple motor. ये आपके पास simple एक motor है consisting of a single current carrying wire or loop. The two magnetic force will act on it here. One is in the upward direction, other is in the downward direction. And what it is creating here, it is basically rotating the body. एक second बेटा just. आज आपकी क्लास की स्ट्रेंथ बहुत कम है. There are only 50 students, I think.
Yes,
Why
sir.
is it? चलो ठीक है. अच्छा अब then obviously it will rotate along its axis. ठीक है. Or how much torque is acted on it, and what equation we will use in order to find out the value of the torque that is acting on a body. So for that purpose, what he has done, that he has shown an example here. Now this example is difficult to understand. Now this figure is difficult to understand. So what I have done is that I have created a simple figure and I will let you know that how it works. So the article, so the calculation which I am going to discuss with you is different from this one. Okay, so be careful about the derivation and understanding. If you have any question at any time, you can ask me directly. Okay, so it should be clear. Otherwise, when you will start to study this one, it will create a lot of difficulty for you, and you will not be able to clearly understand this article. Okay. So for that purpose, what we have done, this is a simple plane here, and magnetic field is out of the paper here like this one. You are एक second बेटा, मैं figure एक second बेटा. Okay, now are you getting the figure, beta?
Yes.
Yes, sir.
जी sir.
Okay, fine. Okay. एक second बेटा. Okay, now this is the simple plane here. Consider it a simple plane in which the magnetic field is coming out of the paper. Okay, and this is the loop of a wire which has the length A, and of the longer length A, and while the shorter length is equal to B here. So in the next step, what we are going to do is K. Yeah. So consider that this loop of a wire is wrapped around on the paper like this one, or along the plane like this one. So you can now assume that the magnetic field is coming out of the paper and it is perpendicular to the length A of the paper. ठीक है, ये समझ में आ गई बात को? Like this one, this loop is, this wire loop is wrapped around the plane of the paper like this one, and magnetic field is coming out of the paper. ठीक है, ये समझ में आ गई बात? Any question?
जी sir.
Okay, so just consider that it is surrounding the plane of the paper. Just consider that this blue surface or shaded region, blue color region, is just a simple paper or the plank, and around it we have this magnetic wire. Okay, horizontal, you can say that it is a horizontal surface, and around this surface we have the this wire. ठीक है, this wire, rectangular wire, which is looped around it. Okay, in this next area, क्या होगा? Obviously we do know that when we place the current carrying wire within the magnetic field, it will exert the force. ठीक है, so we want to find out कि एक सेकंड. अच्छा, अब what would be the magnetic force acting on the two sides here? ठीक है, we want to find out that one. So we will take this longer length. Let's suppose this has the length equal to A, and obviously at the bottom of the paper again it has length equal to A. We will consider it as a side 1 and we will consider the downward longer side as a side 2. Now this one will be, मैं आपको color change करके बता देता हूँ. This one is the side 1 and this side which is at the bottom of the paper is side 2. Okay, side 1 and this is equal to side 3, sorry, 3. So the force that will act on this side will be called as a F1, while this force that is acting on its opposite side at the bottom, at the other end, opposite end, will be called as a F3. So what would be the direction of the magnetic force? ठीक है, क्या होगी in the side 1, this one जो है आपकी side, इसमें direction of the magnetic force क्या होगी? Why I am it as a right side? कैसे मुझे पता चला कि it is acting on the right side? What I will do? क्या करूँगा मैं?
Right hand rule.
Obviously right hand palm rule लगा सकता हूँ या left hand, जी FPI rule. I can use both the rules in order. अब मुझे ये बताएं कि कैसे, मतलब fingers are directed in the direction of the magnetic field for the right hand palm rule, okay, and the direction of the current will thumb will give me the direction of the current. So what would be the direction of the force? क्या होगी?
Normal to the palm.
Rightward होगी. कैसे? The fingers will be pointed in the upward direction, thumb will be in the direction of the current, means that it will be away from you. So the normal of the palm will be in the right direction. So any confusion up to this point? किसी को? Try it on your own.
एक बार फिर explain कर दें.
Fingers will be in the upward direction, beta. Thumb will be pointed away from you. Okay, away from you. So the normal of the palm will be along the right direction. आप try करें. Clear हो गया बेटा?
Yes, sir.
चले. असीब आपका?
सर ये रिपीट कर दें.
नहीं सर, नहीं समझ आई सही
समझ-
तरह से इस चीज की.
अच्छा बेटा एक सेकंड मुझे दीजिएगा. एक सेकंड देख. मुझे एक सेकंड बेटा. अब अल्लाह तो कल ही चाह रहा हूँ, बैटरी का कोई पता नहीं किस वक्त चली जाए, लेकिन चलें ट्राई करते हैं. गर्मी की क्या है सूरत हाल है बेटा आप सब की तरफ?
सर बस ना पूछें, बहुत गर्मी.
बहुत ज्यादा है.
41 सेंटीग्रेड.
49.
मैं क्या शायद
46
कोई मरी
डिग्रीज है
वाला भी
सर.
हमारे पास कोई मरी थी
सर जेल
वाला
में
भी
तो
हो.
गर्मी होती है.
नहीं यार जेल में भी ज्यादा, वैसे मैं लाहौर में ही हूँ तो
लाहौर में है सर जी.
तो लेकिन ये है कि यार ऐसा ज्यादा देयर विल बी अ डिफरेंस ऑफ हार्डली कह लें कि होगा डिफरेंस, कोई मामूली सही होगा बेटा. इट विल नॉट दैट मच बिगर वन. मतलब जस्ट ये है कि लाहौर में इट इज मच मोर कंजेस्टेड, सो ऑब्वियसली the temperature would be, let's suppose if it is 40 degrees, so it will feel like 42 degrees centigrade sometimes.
सर वो यूवी इंडेक्स पर डिपेंड करता है कि हाई हो लो हुआ तो
वो भी है.
टेम्परेचर का फील
दूसरा आपका होता है कि देखिए ना समटाइम्स होता है कि you have lower temperature and but due to humidity you will feel it quite higher. सो इट डिपेंड्स ऑन द एनवायरनमेंट, ठीक है। अगर आप कभी पढ़ रहे हो ना वेदर फोरकास्ट, सो देयर विल बी समथिंग लाइक ओके यू हैव द टेम्परेचर ऑफ 40 डिग्री सेंटीग्रेड, बट आगे लिखा होगा सा कि इट विल फील लाइक 42 डिग्री सेंटीग्रेड और 43 डिग्री सेंटीग्रेड। सो समटाइम्स ये भी होता है, इट डिपेंड्स ऑन द इन्वायरमेंट, ठीक है, कि एटमॉस्फेयर में क्या टेम्परेचर एंड लोअर एटमॉस्फेयर पे क्या टेम्परेचर है। Okay,
बिल्कुल सर।
so I will start the video here, ठीक है। So I was telling you कि आपको बेटा ये नजर आ रहा है हैंड माइक मेरा हाथ,
यस सर।
ठीक है। So अब यहाँ पे देखें कि fingers are pointed in the upper direction, ठीक है, while thumb is away from you. So the direction of the palm is, ये मेरी palm है, it is along the right side, यही नहीं है?
यस सर।
सर मैग्नेटिक फील्ड अपवर्ड है।
Magnetic field is upward, beta. The orange arrow is basically showing the magnetic field.
ओके सर।
Same way, try to find out the magnetic force on the lower end. कैसे होगी?
सॉरी सर, आपने क्या कहा?
सर
Try to
आपकी
find
आवाज
out
नहीं
the
आ रही।
magnetic. Try to find out the magnetic field at lower, magnetic force at the lower end. So what would be the direction? F3 on the F3 side, on the bottom side.
लेफ्ट साइड आ रहा है।
Left side आएगा because in
लेफ्ट साइड पे, लेफ्ट साइड।
because in this obviously beta, because in this scenario the finger is towards you. Again I am sharing my video here, so now magnetic field is like here in this scenario, ठीक है, thumb is pointed towards you. So what is the direction of the magnetic force? Obviously it is towards your left side. This is the palm, normal of the palm is toward left side. So what it will give me, it will give the direction of the magnetic force which is on the left side. So is it clear beta?
Yes, sir.
Asif,
Yes,
any
sir.
question up to this point?
नो सर।
Okay. So what is the magnetic force that is acting on the side one? It is equal to F1 is equal to IL cross B. So what is the length of this wire? It is equal to A. And what is the angle between the magnetic field and that of the current? It is 90 degree. So it will be equal to IAB sine 90. And same is the case with the downward side, but with opposite directions. Now both forces F1 and F3 have the same magnitude, but they are in opposite direction. Clear?
यस सर।
चल,
जी सर।
okay. Now coming toward the side parts. ठीक है, now side parts are different. ठीक है, why they are different? Because now they are existing at some angle rather than at 90 degree. कैसे? Now you can see here this wire is at an angle with the magnetic field. यही है ना, आपको ये नजर आ रहा है ना? एंगल पे है या नहीं? ये देखें, this wire
सर एंगल
is along angle पे है. Now there are two angles I have mentioned here. One is the phi, other one is the theta. Phi is the angle which wire is making with the magnetic field lines, ठीक है, while theta is the angle which it is making with the horizontal surface here. So phi, what is the magnetic angle between the magnetic field and that of the horizontal surface? क्या है angle? क्या होगा एंगल?
90 sir.
90, obviously it is 90 here, like this one it is 90 here, this angle is 90 here. So अब आपके पास क्या है कि what you have to do is कि if it is 90, so phi would be equal to what? Total angle is 90 minus 90 minus क्या
Zero.
होगा?
थीटा।
No, theta. Theta.
90 minus
Theta is the angle which wire is
Theta.
making with the horizontal surface. So phi is equal to 90 minus theta here. क्लियर किया? मैं दोबारा बेटा एक्सप्लेन करूं इस चीज को.
सर एक्सप्लेन कर दे एक दफा.
देखें, आपके पास है दिस इज द हॉरिजॉन्टल सरफेस एंड दिस इज द परपेंडिकुलर सरफेस. ठीक है. व्हाट डू यू थिंक बोथ हैव द एंगल हियर?
90.
क्या एंगल?
90 सर.
90 obviously. Now let's suppose you have some, एक second बेटा, some wire here like this one. So this is the wire here. ठीक है. So the angle which it is making with this one, I am taking it as a phi. The angle which it is making this one, I am taking it as a theta here. ठीक है. So मैं टेक्स्ट के तौर पे ऐड कर देता हूँ. फाई को मैं f से रिप्रेजेंट कर देता हूँ, थीटा को मैं t से रिप्रेजेंट कर देता हूँ here. ठीक है. So the total angle phi plus theta, what it is equal to? F plus t का total angle कितना बन रहा है?
90 सर.
90.
90 degree. Okay. So if I want to find out, so यहाँ पे क्या है? F plus t is equal to 90. Okay. So if I want to find out F, तो F किसके बराबर होगा?
90 minus
is
2.
90 minus theta. So is it clear to you now, beta? अब क्लियर हो गया?
जी सर, बेस्ट हो.
चलें, गुड हो गया. चलें, so this is the angle here. So again we will use this relation IL cross B here. What is the length of the side? It is equal to B here. So I will take it as a B. What is the angle here? Phi is equal to 90 minus theta, but we do know that sin pi by 2 minus theta is equal to cos theta. ठीक है. So cos theta हो जाएगा F3 is equal to, आपके पास क्या आ गया? This relation. In the same way क्या हो जाएगा आपके पास in the F4 जो होगा, ठीक है, this side it would also
सर
be
ये
equal
F3
to
आएगा या F2 आएगा?
F2 है बेटा, सॉरी गलत लिखा गया, F2 है. मेरी गलतियां तो यार फौरन पकड़ लेते हो आप लोग हैं. F2 है बेटा.
नहीं सर.
सर आप भी पेपर में पकड़.
चलो ठीक है, डन हो गया फिर.
नहीं सर, छोड़ दीजिएगा.
मोहम्मद इस्लाम अमजद.
सर गलतियां सर से होती हैं.
इसी तरह यार. अच्छा, दिस साइड इज F2. सो बेसिकली बेटा ये गलत है, उसने एग्जैक्टली सही कहा है. ये मेरी साइड पे गलती थी बेटा. सो इट इज F2 here and this one would be equal to F4. ठीक है. So this is the F4 here. ठीक है. So both are the same one, but the thing is कि बेटा both are in opposite direction. ठीक है. So what we have seen so far that F1 and F2 are same in F3 are same in magnitude, like this one and this one at the bottom. Both are same in magnitude, but both are in opposite direction. So net force due to the length A of the wire is equal to 0. In the same way, आपके पास ये है F2 and that of the F3. They are equal in magnitude, but again they are in opposite directions. So net force for the length of the wire A, or the component of the wire having length B is equal to 0. So it means the total net force that is acting on the loop is now equal to 0. ठीक है. अगर टोटल फोर्स इक्वल टू 0 है तो फिर टॉर्क कैसे प्रोड्यूस हो रही है यार? मुझे तो ये समझ नहीं आती.
वो ऑपोजिट डायरेक्शन की वजह से.
नहीं, अपोजिट भी हो तो नेट फोर्स तो इक्वल टू 0 है. कोई एग्जांपल देना चाहेंगे मुझे आप? कोई ऐसी चीज जो आपको लगे कि वो टॉर्क प्रोड्यूस करती है लेकिन फिर भी नेट फोर्स इक्वल टू 0 होती है.
कॉमन एग्जांपल
पोजीशनिंग का डिफरेंस की वजह से.
किसकी वजह से बेटा? सॉरी बेटा, आपकी बात समझ में नहीं आई.
सर इन दोनों फोर्सेस का लाइन ऑफ एक्शन सेम नहीं है.
यार एक बिल्कुल कॉमन एग्जांपल है. आप लोगों ने पढ़ी हुई भी है। कपल
Basic
बोल
generator.
दो आप लोग, कपल बोल देंगे?
नहीं सर, नहीं भूल।
The steering
कपल
wheel.
फोर,
नहीं, टर्निंग इफेक्ट
wheel,
ऑफ फोर्स।
हाँ टर्निंग इफेक्ट। नेट फोर्स किसके बराबर होती है वहां पे?
सर नेट फोर्स 0 ही होती है।
जीरो ही होती है, बिकॉज टू फोर्सेस इक्वल in magnitude but in acting in the opposite direction separated by a small distance, so they basically do the turning effect, rotation effect. So someone will ask you, okay ji, if net force is acting on a body and then how it is creating the turning effect, so you can give him the example of the couple. Okay, in the case of the couple, obviously we have the two forces that are acting in the opposite direction and they have the same magnitude, so net force is equal to 0 but still they produce the turning effect. ठीक है, so rotation along the axis of the rotation जो है वो इनका center होगा. So now we will discuss about the turning effect of the body. So up to this point we calculated the force that is acting on the each side of the loop of a wire, and now we will see that how it will create the turning effect on a body. ठीक है
सर 1 मिनट रहे।
चले मैं एंड कर लूं, फिर नेक्स्ट क्लास स्टार्ट करें बेटा।
सर आज के लिए इतना ही काफी।
ओके सर।
नहीं बेटा, ये खत्म करना है शाह नहीं, ये छोटा सा ही है आप बेटा, लास्ट ही है इसका, एक लास्ट स्लाइड है नेक्स्ट वन। ठीक है बेटा?
यस सर।
तो आई एम
यस।